A very good morning to all of you. Now let us look at the second part of the unit that's on special analysis, and this time we are going to do a modeling or analysis called as least cost path analysis. Before going on with the practical, I would like to make you acquainted with what is least cost path analysis. By the name itself, it suggests that we have got least, we have got path, and we have got the cost. This analysis is going to lead us to paths between a source and the destination, which is costing the least. So if we have to define what is least cost path analysis, it's basically a distance analysis tool in GIS, and this distance analysis tool will give us or will generate paths between a source and a destination that will be least of the cost as well as cost effective. So this is what least cost path analysis gives us. Essentially, an analysis technique in GIS helped or assisted by different distance analysis tools in GIS, and this analysis will basically lead us to generate so many paths, and these paths are list of all the different kinds of paths between source and destination, and from this path again we are to choose only one path which is the least of all the cost and least of cost and cost effective compared to all the other paths. So this is the definition about least cost path analysis. I've written whole documents and steps to how to do least cost path analysis. I'll be giving documents with the practical with you. You can read the definition through the document. All right. So having known the definition, let us just look at the steps in doing the least cost path analysis. There are about 30 steps that we need to go so that we can do the least cost path analysis completely. It starts with preparation of required data layers, to calculating distance, to exporting a model to image form. Now let us start. The first foremost thing that we need to do is create a folder called as least cost path without any space. Even if you want to leave space, you can leave space, but try to know that this is the folder that you're working with. For the consistency, we'd like to I'd like to work with a folder name as least cost path without any without any space here. So I'll be creating this folder under my working folder. So we have been creating our working folder. In my case, it's doji underscore CNR ArcGIS. In your case, it's either your name and your course and ArcGIS. So under that one, we are going to create a working folder called as least cost path. So just go here, and this is my working folder over here. Working doji underscore CNR underscore ArcGIS. Under that one, I'll be creating a folder called as least cost path. So this is the first thing that I have to create, and this is done now. So I'll be checking this one. Now let's go to ArcGIS over here, the ArcMap, and the first and foremost thing that we now need to do is prepare the required data. So in this practical, I'm specifically taking a project to make a path or a farm route between Phongme's last endpoint to Sakteng. So right now we have farm route from Phongme to Sakteng, but the data that we have do not have the route from farmer from Phongme to Sakteng. So the farmer from Phongme to Sakteng is very recent, and we'll just assume in this project that the road is not being constructed so far. So we need to construct a farm road from Phongme to Sakteng. So this is the project that we are going to handle now. For that one, I'll be needing a boundary of Phongme, Sakteng, and Phongme as well as Sakteng. I need a boundary for Phongme to get an idea where till where the route has reached, so that the end point of the route will be the starting point of our project. And I'll be needing the boundary of Sakteng so that I can clip out settlement falling only in Sakteng, and so that I can create the end point of our road looking at the settlements. I need both the Phongme and Sakteng as an overall boundary so that I can add LULC and I can add DEM file so that I can do overall analysis in this both boundaries. So for this one, I'd like to take Phongme now, Phongme separately, Sakteng separately, and Phongme Sakteng. So firstly, Phongme. For this one, I go to catalog, and I just go to my data, and I go to national data. Right, so under national data, I'm going to go to Geox, and under the Geox, I'll be just taking out Phongme and Sakteng separately right now. So this is Tashigang. So wait, this is Phongme. So I just take Phongme separately for now. Then I'll just go to selection, create new. All right. So this is Phongme. I'll name it as Phongme immediately. Second one that I need to do is for Sakteng. So let's create for Sakteng again. All right. So let's again go to Tashigang and go to Sakteng here. I'll just click close and selection. All right. So this I'll be renaming it as Sakteng. And now the last boundary that I need is Phongme and Sakteng together. So again, for this one, I'd like to go to Geox, and this time I'd like to choose both the Geox by clicking Control on the keyboard and selecting both. And this time, I'm again going to go to Geox and go to Selection. This time I would like to select both. I'd like to name it as Phongme underscore Sakteng. All right. So this way already, I'd like to take or remove out the Geox immediately. Let me just drag it down and let's just see whether. All right. So this is Sakteng. This is Phongme. This is Phongme. All right. So this is Phongme Sakteng. Yeah. So all the three layers are ready. Now let us just check out road till Phongme, just to see where exactly the road has reached. For this one, I'd like to bring in Michi roads, and I see that the road has actually reached to. I'll just check this once, and I see that road has actually reached to the Phongme over here. And from here, we need to construct a road that goes to Sakteng and that connects with Sakteng. All right, so I go to geoprocessing, and here I'd like to choose clip and clip the road falling only in Phongme. And clip feature is Phongme, and this time I'd like to save my upper feature class in in a folder which I have to connect to the folder, and since I have not connected, so I have to connect the folder. It's in working lecture. So here, and I'd like to connect this one so that I can save it in this course path, and I would like to save it as uh, Phongme root clean. So just save. That's it with this one. I'd like to click OK. Right, the clipping has been done. I'd like to remove BT roots from here. And I'll just see that the root has actually reached to only Phongme hill. Now the next thing that I require for my layer is settlements falling only in Sakteng. So for this one, I'd like to go to uh, just uncheck Phongme root and Phongme for now, and I'll just check Sakteng. And for this one, I'd like to drag in settlement to ref, and I'd like to clip settlement of falling only in Sakteng. So input feature is settlement to ref, and clip feature is Sakteng. All right, and I'd like to save it in that folder, list cost path folder with the name Sakteng. Okay, settlement. So save it, and just click it OK and let it process. All right, the processing is done now. Again, I'll uncheck. I'll remove settlement and just keep Sakteng settlement. I'll see that the green ones are with the settlement falling only in Sakteng. I'll uncheck Sakteng and set Sakteng settlement. And for now, I'd like to add another layer. That's LULC of Phongme Sakteng. So land use land cover data has to be added. It should be under land cover land use. So add or use land cover data 2016. For this one, there are three kinds of data over here. What you need to use is you need to use the middle one. That's a shape file. So just drag it, and the loading will take slightly a little time, and then more than the other data, because this is LULC data and it has lots of information. All right, LDLC 2016 it's being launched now. I need to now clip out LDLC falling only in Phongme and Sakteng. So for this one again, I'd like to go to your processing clip, and input feature is LULC 2016, and clip feature is this time Phongme and Sakteng. And again, output feature class, I'd like to leave it as Phongme Sakteng LULC. I'll save with this name, and I'll click it OK for processing. The processing time for clipping of land use land cover will differ from computer to computer, so you need to have some patience, because as I said, LULC data is quite huge and massive. It has lots of data in it, so clipping or usually any kind of tools or analysis function for LULC will take time, so please have some patience. Right, the clipping of LULC with the Phongme and Sakteng boundary has been completed. Let's just uncheck LULC for now and let us see. All right, so LULC falling only in Phongme and Sakteng has been clipped now. Just to give you a brief background on what is LULC. Land use land cover data is a data for the for a place which is being defined by what that place has the coverage of vegetation, of settlement or agriculture. So basically, a place covered by anything else, that data will be represented by what a land cover is all about. So what is that land being used by any feature, or is that land being covered by any vegetation, is what uh, land use land cover data is all about. Land cover, basically, if we are looking at the vegetation cover and the natural cover. However, if you look at land use, we are looking at the natural land that's being used for different purposes. So, land use land cover data is a picture of land having a natural vegetation and all, as well as land that's being used for different purposes. If you uh, let us just go to Phongme something LLC, it's the same thing. So same kind of data will be there. Or like if you want to go to LELC 2016 data, and let us just look at properties, and let's just look at the symbology of that one, and let us see what kind of data that we have in LELC. So if you just go to symbology over here, and right now it's in uh, it's in this color because it's just a single symbol. If you just categorize, and if you just look at the different classes of materials that this land use land cover has, and if I just add all the values of this class, um, we see that there are lots of records, and that's climbing to 20,000. So these has this different kinds of classes of data. For example, I'll just apply it and click it like this. All right, if you just look at this data, I'll just zoom in just for explanation. It takes time to load because it's quite huge. So if you just look at the table of content over here, um, the dark blue ones, if you see here later when it gets fully loaded, the dark blue ones are alpine scrub. The red ones, wherever you see the red ones, are basically the built-up area where we have got buildings, where we have got roads and all. These are basically built-up area by human settlements or any kind of human constructions. Then we see that light blue are ones which are having the cultivated agriculture, and we have got a green forest, landslide areas, the meadows, the moraine, not built up area, rocky outcrops, shrubs, and all. So, yes, if you look at the upper region of the country, which has dark purple color, that's basically snow and glaciers. So, land use land cover data is basically a data which comprises of what natural vegetation our country has, firstly, and secondly, what are those lands being used up with what kind of activities? Like, for example, built up areas, cultivated agriculture areas are what land use land cover data talks about. So, because of that, it really takes time to process and all. So, this is a brief explanation about land use land cover data. The reason why we are using a land use land cover data is because we need to land use link data gives us a clear idea about uh, how and where should our paths or our farm roads should be constructed. For example, pass our if we pass our path from forest compared to rocky outcrops, forests will have lesser cost because we do not need to dig away, or we do not need to cut all the big rocks and rock outcrops. We do not need very huge machineries compared to rock outcrops for forest. If we are to take our road from already built up areas, that we are affecting people and their livelihoods. So we do not want to disturb built up areas. We don't want to go with moraines because these are not very stable. So these kind of things, we do not want to go through water bodies because uh, after going through water bodies, it will cost a lot because we need to construct bridges and all. So as far as possible, we need to uh, go through go through areas of land use land cover where it's going to cost us least. So that's why we are analyzing legislative cover. So I'll just keep this Phongme Sakteng legislative cover for now. And the last one that we need to take out is Phongme Sakteng Dam. And the reason why we are taking out dam is because later part we need to take out we need to take out uh, slopes, which also has a huge factor in determining the least cost. So I'll just uncheck the legislative cover and take out slope. Take out dam falling only in Phongme Sakteng. For this one, I'd like to go to catalog and add from the dam folder here, Amsterdam Bhutan or any dam that you have, dam Bhutan or Amsterdam Bhutan. So it's on you. I'll just take out Amsterdam Bhutan over here. And all right, so this is dam being added. I need dam only for Bhutan. So this is dam for overall. So I do not need a dam for whole Bhutan or whole region, but I just need a dam for Phongme Sakteng. For this one, I'd like to go to a tool, and like I said, to clip out raster file, which is damp here, we need to have another tool called as extractor. So to get extract by mask, we need a tool called extract mask to extract out damp. To get an extract by mask, we need to go to special analysis tools and go to extraction and use a tool called extract by mask over here. So I'll be double clicking this extract by mask here, and the input raster will be as a damp here or any kind of damp, and the input feature or marks data that I want to cut it out will be Phongme Sakteng boundary over here. And this time I'd like to again save my output raster as uh, Phongme Sakteng dam. So just save like this. I need to put it TIF. Alright, so let it process. Alright, extract mask is being successful now. Uncheck or remove the acetadam, and I'll just keep acetadam falling only in Phongme and Sakteng area. Zoom to layer and let me uncheck this one. Right, anyways, this is the dam for Phongme and Sakteng. So from here on, our layers are ready. So we have boundaries ready, root, settlement, LELC, and dam ready. So boundaries are needed in order to take out root, Phongme for root, Sakteng for LELC, and Phongme Sakteng boundary for LELC, as well as dam. So now the second step is to create origin under least cost path folder. So let's just create an origin. Origin basically is a point at the least cost path analysis. So let us create origin now. The origin of okay, let me just click Phongme. Not like all right. So all right. So I'll just go to this one and Under this folder, list cost path folder, in the catalog, we need to create a layer or a shapefile called as origin. So I'll just create a shapefile, and the shapefile will be a point, and the name of the point will be origin. And to give the coordinate system, I'll be giving PCS to graph, and just click it OK. And we see that the origin has appeared here, but nothing is over here. The origin has to be the end of the route in Phongme, where our project of list cost path will start. So that's why it's the origin, and the destination will be somewhere in Sakteng. So to create the origin, need to turn the editor on. All right, so I'll just start editing because we have just origin, but we do not have any point. And click the origin that I need to edit on, and click it OK. All right, so the editor is on, and we need to now go to create feature, because we need to create a point feature over here, and click on origin once so that the construction tools will appear here. Click on origin, and I'll just click on point, and I'll just zoom in for a while so that I exactly pinpoint where should I start my origin at. Right, so I should start my you can use up down or like left right key or arrow on your keyboard. I need to point exactly at the end of the Phongme road as my origin. So I have clicked already here. I go to editor, I'll save my edits, and I will stop my edit. So my origin is over here. I'll just make it conspicuous by okay, so the triangle is my origin, and I'll just go back to the zoom to layer. So this is it. I've created my origin. The triangle one is origin. Now next one is I need to create a destination. So when I want to create a destination, I have to create a destination in Sakteng over here, because we need to join Phongme and Sakteng road with the farm road, and the destination should be in Sakteng. To get a destination in Sakteng, we need to use the Sakteng settlement data. The reason why we are using the Sakteng settlement data now is because when we are starting from Phongme and ending at Sakteng, we want to add and at such a strategic point in Sakteng that all the settlement will be benefited by the route. So we do not want to end our route in such a place like around this area where the people are not able to access, and where people are not getting benefits from this route. We want to create route at such a mean point or a center area where all of them have equal chance of accessibility to the route. So for this one, I'll be using a tool called as mean center. Basically, I want to create a mean of the settlement of the Sakteng. So for this one, I'll be going to Arc Toolbox, and I'll be going to special statistic tools, because we know that mean is one of the statistics. So I'll be going to special statistic tools, and this time I would like to go to measuring geographic distribution. So go to measuring geographic distribution and go to mean center over here. So double click mean center, and it's asking input feature class. So I'd like to give Sakteng settlement as input feature class, and it's saying where do you want to save your mean center at. So I'd like to save it in this folder itself with a name called as destination. So this is my destination, and just leave other fields blank as default and just click it OK. Let it run. So our min center is being completed now, and the large circle dot is what our min center is all about. So it's saying that the large green dot is the centermost points of all the settlements. So this is a uh, perfect endpoint of our route. So we need to start from the origin over here to the endpoint or destination of our route in Sakteng. And the question is, how do we create a route from Phongme to Sakteng, and where should be our cheapest route? Where should be our cheapest way going through this land use, land cover, and dam detail? So that's main thing that we are going to now analyze. Next thing that we need to create is so we have already created a destination. Now next thing we need to create is a toolbox. So let's add a toolbox and name that toolbox as least cost path. So for this one we need to go to toolbox, and I'll just minimize all of this, and on the arc toolbox button over here, just right click it and go to add toolbox, and this time we need to create a toolbox inside our right. We need to create a toolbox inside our that same folder, list cost path folder, and I'm going to create a new toolbox over here. Name that new toolbox as list path analysis with the space. So I'll just name it as, just click it once like this, and list path analysis. All right, so just click it somewhere outside the name, and again click it back so that you open that same toolbox. I'm saying again, rename that toolbox that you have just created from here as list path analysis. Click somewhere outside so that you validate its name. And secondly, to open this toolbox, because we need to open this toolbox and edit in our arc toolbox, just click it once and open it. And when you open it, you should be seeing it as one of the toolbox under the arc toolbox as list path analysis. So it should be at L. So this is all arranged in alphabetical order. So this is L over here. So with this one, we are done with the creation of our toolbox and naming the toolbox as list path analysis. The next one is we need to create a model builder. Model builder is quite handy if you have to add lots of tools, and if you have to build lots of steps, and if you are getting confused, model builder will always tell you where to go, and if there are some error at last, you have worked thoroughly for 2 to 3 hours, and at last you feel that you have got a wrong answer, model builder will always tell you where did you go wrong, and you can instantly rectify your error through model builder. All right, so it's advantage to create model builder. So let's create model builder. Create model builder. So to create a model builder, you can always create under that toolbox. So just right click the list path analysis toolbox and just go to new and go to model here. Just click it model over here, and it's not just model that you can create under the toolbox, but you can also create you can also create a tool set where you can add different kinds of tools that you want to use daily under this tool set. So you can also do that. For now we just create a model, and model is here now. All right, we have just created a model. Now we need to give some properties to the model. So we need to look at the uh, we need to give the model with a good name. We need to do some editing with the workspace and rest of the things. So for this one, let's just go to model properties now. Go to model and let's go to model properties over here. And when you go to model properties, the first thing that we need to give is the name. Give the name as LC path analysis. Here you cannot keep any space because the name of the model should not have any space. If there are any space, then it will not be acceptable. However, in the label, you can keep space. So label is how you want your model to be named or come out as. So this is the label. You can write label with the space. And we can now go to environment, and in environment I want you to specifically go at features. Oh, sorry, it's not feature, but in arc template I think there's no feature. uh, let's directly go with the workspace here. We need to define the workspace. So in the workspace, we have current workspace and scratch workspace. So we need to define where exactly we want to save whatever process that we are doing in the model, where exactly we want to save that one, and we want where we want to save again the scratch scratch outputs which we do not want, but still the system gives us, so we want to save that one. So we would like to again define the workspace for that one. So just check and go to values in order to define these one. And here it's asking where you want to keep your workspace for the current modeling as. So let's just go to this one, the folder, and let's just define the that we want to save it in the folder that we are working with, where we have got list cost path, where we have got list cost path. All right, so this is list cost path. Just to check the name, you can go to down and just click it your left or right arrow, and yes, I'm add list cost path folder here. Just click this folder and just add it so that the file path comes over here. I'm saying to the model that I want to save everything that I'm working with at this path. And I'm again saying that whatever scratch things that are generated from the modeling, I would like to save it in this path. So basically giving the two paths the same folder. Okay, all right. So I'll just click OK. The next thing that we'll be looking is let us just look at the processing extents. Yes, let's just look at the processing extent, and let's just go to values of processing extent. Let's just magnify this processing extent. If at all, if you have to process, or if you have to do some analysis, which is the boundary that we want to confine our processing tool. That's what processing extent is asking. So I'd like to say that our our analysis should be around at the same layer as Phongme and Sakteng. So we shouldn't be going out, and just click it OK. And let us just look at again some of the things like raster analysis. So if you have to do any kind of raster analysis, for example, astrocarp mask, then what are the things that we need to do around here? So let us just define some raster analysis like here. Cell size is usually a 29.35 something else meter by 29 meters. So it's asking exactly if you have to do any kind of raster analysis, then the cell size of output feature class, which layer you want to match that cell size with. So I'd like to just choose Phongme Sakteng dam over here. So it's around 29.34 meters by 29.34 meters. And mask, it's asking which exactly is the mask that you want to use. So I'd like to just use Phongme Sakteng as marks, like general marks. So just click it OK. And I guess that's it with the raster analysis and work processing extent and workspace in the model. So just apply it and click it OK. And I see that now, because we have given label as LC path analysis, the label has appeared over here. So that's it with the creation of model, and we'll be working with all the steps in the modeling. So we have given the name as LC path analysis without any space, but the label we give it with the space. We have defined workspace, we have defined processing extent, we have defined the cell size 29.324. We have again given or assigned the marks in the model properties. Right, so the next process that we have to do now is to derive slope. So remember, we can derive lots of things like slope, aspect, contour, topographical images from raster dam. So we can also derive slope this time from dam. To derive slope, now this time we will be using all the tools inside the model builder here. So let us just use a tool called as slope, which we can get it from special analyst tool and from abstraction. Sorry, it's not from abstraction, but I think it should be from surface, where we are generating surface from dam, and we can have slope here. We can drag slope from here and leave it over here, and slope comes over here. Or we can also, if you just know the name of the tool, we can also use the search function and click the name of the tool that we want to use in the search function. So for now, I'll be using slope. So I'll just click slope. And it's please be mindful over here. Sometimes it's showing us result same for the slope, but it's for 3D, and they are again 2D. So the slope tool that we have to use is not for 3D, but it's for 2D. So it's under special analyst tool over here. The first one is the tool itself. The second one is the a description of what the tool does, and the third one is where exactly the tool is located inside the ArcTool box. So the first one is a tool. You can directly drag it like this, like the one that you have dragged a year ago from ArcTool box, and just leave it over here. Just drag it and leave it. And you need to now double click on the slope, and the input raster that you want to feed the slope with, which you want to take out slope, is dam, and the output raster that you want to define it is you can directly call it as slope. But before that, just notice the file path here. So now it's directly going and saving in this cost path without having to define through this folder. So I can also always click, I can always write my name from directly from here, leaving the div in there. I can always write it as slope only, or just slope Phongme. I can write it like that. Uh, so for now, I'll just write it as Zong slope, and Zong slope is the slope for that area, Zong's area. So I'll just keep the output measurement in degree. So there are two kinds of measurement for slope. One is percentage and one is degree. So I'll just use degree for now. Z factor, just leave it as 1, and method is planar, and just click it OK. And as and when we have clicked the uh, inputs, then to and the outputs, just try to arrange it properly. And this is for auto layout, giving the layout a very good standard look. And the second one is for full extent, where it will extend looking at the space that the model has. So the reading is, the yellow one is the tool, blue one is the input feature, and the green one is output. So it's going to be same in the model for all of the analysis. So right now it has just given, it has just given the input and output, and it has not run right now. So it's very important for us to run. So just right click it or run it, or just click it once over here and just click run over here. So just right click it, just run it, and it's going to run. All right, the run is successful. I'll just close this one. And what we'll observe is that right now the slope is being successful. Taking out of slope from them has been successful, but you're not seeing any slope in the arc map. It's because you have not displayed. So it's very important for us to display from the output feature class as right click it and add to display. So when it adds to display, then it will display the slope. So I'll just make Phongme and Sakteng hollow. Now the slope is being displayed over here. So that's it with the derive of the slope. Second one is we need to now reclassify the slope that we have just derived. Remember that reclassification works only for raster file. So whatever things that we need to reclassify, we need to convert to raster file every time. All right, so we need to now reclassify. So I'd like to go back to again search and choose a tool called as reclassify. This time again, do not choose the 3D analyst, just choose special analyst to classify, and just drag it over here. Again, double click on reclassify, and this time I would like to reclassify Zong slope, and the reclass field is value. And I'd like to classify. Click on the classify, and the classification method that we are going to use is quantile. The number of classes that we need is 10. So just leave it at 10, and do not have to do anything else. Just leave it at 10. But note that 1 is the most plain ones here. So 0 degree to 12 degree is from 1. So that means we have classes from 1 to 10 over here, and the 10 is the steepest ones, like 40 to 69 degrees. So these are very steep areas. And upper roster as class zone. So just write it as slope reclass. That means the slope is being reclassed. So the file path, you do not have to do anything else, and just click this one, change basic value to no data. It's very important to check this one because later what happens is that there are some values which are not seen over here and which are not being given new values because it's missing from this one. However, at times it may appear back during our analysis, and these missing values will show up and it will just mess up our whole analysis. So it's very important to check missing values to no data. Just click it, you can apply it, and just click it OK, and I'll just auto layout it and let you see. So it's getting connected. The end product of the slope is the input of the reclass file. So I'll just again right click it and just run it. All right, the reclassification is being successful now. I'll just close this one, and I'll add to display this one. The reason why we are adding to display every time is because we need to see our changes. So if you want to see our changes immediately, then we need to add to display every time. But it's not mandatory for us to add to display every time. We can add to display at last tool. So it's your choice either to add to display immediately after you have run the tool, or to add to display at last. All right, the next process, let us see where are we. So the next process is to convert the land use land cover 2016 to raster. So we need to now convert the land use land cover of Phongme and Sakteng to raster. So for that one, we need to use the tool called as polygon to raster. The reason why we are using polygon to raster is because land use land cover is in vector form right now, which is in polygon, and we need to convert that into raster through this tool. And raster to polygon is a conversion tool here. So sorry, polygon to raster. So the reason why we need to again convert LULC polygon to raster is because we need to reclassify LULC. So without reclassification of LULC, less cost path analysis is not possible, and without using polygon to raster, LULC, which is in vector format, cannot be converted to raster. So we are using polygon to raster for that reason. Input feature is Phongme Sakteng LULC, and value field. This is quite important. Please try to note this one. What exactly do you want to convert when it comes to LULC? When we are converting from polygon to vector, it's class, because we saw that you have got different kinds of classes like agriculture, low, built-up areas, low, moraines, low, and water bodies, and all those different kinds of classes needs to be converted. So please choose class, and upper raster is Phongme Sakteng LULC. So I'll just write it as LULC raster, and cell assignment, just leave it as it is, and The priority field, just leave it as it is. Cell size, we have defined cell size from the model properties to give it as Phongme Sakteng demo. That's why it's coming by default. So just leave it like that. Apply it and make it okay. All right. So I'll just again uh, just make it to a good layout. Now I need to right click it again, run it. All right, polygon to raster is completed now. Let's close it now, and again make it add to display. So by end of this conversion, what we need to know is that now all the LELC should have been converted to raster now here. All right, so let us look at the LELC part over here. Just check the slope, and I check the zone slope over here. So LELC raster is being converted to LULCB is being converted to raster, and the raster has different classes: forest, meadows, shrubs, and all. These are the classes. All right, so let us look at the next process. The next process is to now reclassify the land use raster, so LULC raster. So for this one, again, we need to go back to our search and add reclassify tool and drag it reclassify tool over here. This time for reclassification, we need to reclassify LELC raster, and it's very important to choose the reclass value from here. So try to choose not value, but try to choose class, not even count. Please choose class because we need to reclassify the classless. So I'll just choose class like this, and for now just leave the classes 10. It's just okay, and even the name can be just left as a class LULC, and change the missing value to no data. So from here, the important thing that you need to keep in mind is reclass field is not value or count, it's class. Just apply it and click it, and we need to now run it. All right, the reclassification is now over. I'll just close this one, and again I'll just auto layout and add to display. So let us see exactly how it's being reclassified. So LELC class is being done over here. Now the next process that we need to look at is a weighted overlay here. So we need to now give weight to the reclassed raster. So we have reclassified slope and we have reclassified land use, land cover data. Now weighted overlay will assign weights to those which will cost the cheap price to construct the road, and through this kind of assignment we should be knowing where our route should be traveling, where our cheapest road should be traveling, and where our expensive road should be traveling, and we should be able to get some idea from this one's. So now let us look at the weighted overlay. To go with the weighted overlay, we can go to our toolbox and you can go to special analysis tools, and we can also go after that we can go to overlay, and from there we can see weighted overlay over here. If you have to go through search, we have weighted overlay, and just click enter. So we have weighted overlay in special overlay, special analysis over here. So let's just bring back our model, and this time I'm going to drag in wedge overlay over here, and double click the wedge overlay. And first thing that you need to do is you need to add those two layers, those two reclassified layers to this field. So I'll just drag in two things. I'll drag in slope reclass, which we have reclassified. So it's asking which is the field that you want to add into wedge overlay. For slope, it's value, obviously, and slope will come here. And for another one, which is reclass LULC, and it's asking which is the input field that we want to take out. So I want to get into class, and I want to add class LULC with class in the wedge overlay. So I've got two things now here. Here what you need to know is firstly the percent influence layer. So we have got slope reclass and reclass LULC. Out of these two layers, if you feel that slope has more to do with the cost of our farm roads from Phongme to Sakteng compared to different kinds of land use land cover, then you're going to give more. Let's say 60, and when we enter 60, some kind of like a cross mark warning sign will come out here. It's coming out because the influence percent should be 100 like total. So we have got two layers, so if one layer is 60, the other layer should be 40, so automatically it will go up. So the influence percent should be a total of 100. That's if you feel that slope should have more influence, but if you feel that slope should have around 30 and LULC should have around 70, again that's on you. So for now, let's see that let's say that both should have 50-50% looking at the influence that the both will have. And now we need to assign the scale values. So if you observe these are the values. 1 to 10 are the values of the reclassed slope, and I said, if you just remember a few minutes ago, I said that one is the one is the area where the slope is quite flat from 0 to 12, and 2 is little bit steeper from 0 to 12, or 1 is more than 12 degree, 2 around 40 to 50 degrees. If you look at 3, it's more than 50 degrees. But if you go till 10, the 10 is around like more than 60 degrees. So the main thing that I want to tell you is that from 1 to 10, the cost of construction of path or the farmer from Phongme to Sakteng will increase as you increase with 1 to 10. And even the scale value that we need to give should be the same. The lesser the scale value that you assign, the least the cost of the path. So I'll just assign equally for all of these. However, I'd like to all right, so I'll just give this as scale value of 9, or like restricted, or 9. Restricted meaning you're not allowed to construct road over here, so I'll just give 9. And I really hope that you are knowing what the meaning of this value and scale values are. If I just explain again, 1 is around like flat area, and we are giving scale as 1 because it will be the cheapest to construct at flatter slope area compared to very steep area of 10 or 9, which is around like 40 degree or like 50 degree or like 60 degrees key slope areas in it. So that's why we are giving higher cost. So 1 to 10 is the cost. The cheaper is 1, and the most expensive is towards 9 and 10. The reason why we are having again 9 as the maximum is because it's the evaluation scale is from 1 to 9 by 1, and if you have if you just want it by 5 or to 1, then we can also get it by here. So just we have just chosen from 1 to 9. That's why highest is 9 here. We can also choose 1 to uh, 10 by 1 also over here, and just click it enter, and we should be getting sorry, I'll just get back to open this one. uh, the good thing about attribute table is that we can always open like here. So I've just chosen the 1 to 10 by 1. I can also write evaluation value here. So I'm choosing 1, 2, 3, 4. I'll be choosing this as 5. I'll just give equal scale for the field. This one as 9 and 10. Right, so the second one over here is that uh, if what is the cost that you feel if our farm road goes through forest. So for forest, I think it will be cheaper, probably cheapest. We just need to cut down some trees and all. But if you go to meadows, it will be slightly expensive than forest. If you go to shrubs again, okay, if we want our roads to pass from shrubs, it's okay. We can clear some shrubs. Up in scrubs, I think it will be quite expensive. Just give it 5. Landslide, totally expensive because it's quite expensive. Water bodies, let's not choose. Let's just restrict ourselves to water bodies. Let's not lead our farm road to pass through water bodies. Snow and glaciers, very expensive. I think 9. Cultivated areas, quite expensive. 4. Built-up areas, I think we should not be restricting our data. Rocky outcrops, very expensive. I think 9. So this kind of scale values can be given, or like this can be 2. Okay, so this kind of scale values can be given to the areas depending on its expensiveness. So landslide can be 10, I guess, and for one rocky outcrops can be 9, and snow glacier can be 8. All right, so this no data can be kept as no data itself. So that's it with the weighted. You are assigning weights based on the cost that's these values or class can have. So I'll just keep this name as cost roster, because we are looking at the cost over here, cost roster, and we are saving in the same folder path. Just apply it and click it OK there. So I'll just arrange it properly. All right, so I've just done widget overlay of this LULC and slope. I'll run it. All right, the widget overlay has run properly and it's successful. Now close it and let's add to display and let us see how does our cost roster looks like. Just check everything else and just leave the cost roster. Okay, so this is the cost roster, and it's clearly showing that the rate ones are the cheapest ones. Wherever the rate ones are there, they are the cheapest one, and they are what feasible for our road to pass through. The green ones are those ones which are very expensive to for our roads to be constructed. All right, so next one is calculating the cost distance now. Let us now calculate the cost distance. So we go to ActualWorks and we go to Special Analysis tool. Sorry, special analyst tool, and under that one we go to distance and cost distances over here. All right, so we can now drag cost distance from here, or we can search from here also. So it's the same thing. I'll just drag from here cost distance and enlarge it, and again right, so I'll just click cost distance now, and it's asking a few very familiar things like input raster or feature source data. So we have source or origin, right? So this time it's going to be useful. It's asking source, so let's just look at origin and give origin here. It's asking the source data, so that's basically origin. It's asking input cost raster, the cost raster data that we just had from weighted overlay, cost raster over here. And by the way, when we are doing drop down and we're seeing two kinds of things. One is in blue and one is in normal layer brown button of here. It basically means that these blue ones are on the model and these ones are not on the model, but these are still in the ArcMap. So if they are on the model, then they, for example, these Zongo slope and all should have been blue in color. So that's just a difference, but it's still in the ArcMap. Everything is in ArcMap. So this is what we have now done. So from here, the output feature class that we need to give is cost distance here. So cost underscore distance, and just leave the maximum distance just blank, and output blank backlink raster. This is quite important to define. So later on in the next process, it's going to ask where is your backlink. So that's when we are to get the backlink. So just go to the folder and just save our backlink in the folder that we are working with here, and just leave it as backlink. It should be fine. Backlink. So it's just a backlink over here, and apply, and click it OK. All right, so let's just try to arrange it and auto layout. All right, so I'm just going to now run this. All right, now cost distance is being successful. So now we need to go with the next process, which is cost path. So for this one again, whatever things that we have added in the model here will be handy. For example, the backlink 1, the cost distance origin 1, all these things will be handy. Again, by the way, if I just want to if I just have to interrupt in order to give you more information about the model, the green ones over here, we can also rename it. You can also rename it with any name that you want to redeem your output with. So you can also redeem the backlink. You can basically redeem all the output feature classes over here. All right, so getting back, the next thing that we need is the cost path over here. So just drag in the cost path. And for the cost path, it's again asking some familiar things. It's asking input raster or feature destination data. So here we're going to give the destination, and it's asking and in the destination field you just give ID, and it's asking input cost distance raster. So we have just calculated the cost distance raster. So you just give the cost distance origin here, cost distance raster over here, cost distance raster. By the way, it's this is the cost distance that we just got from the cost distance tool over here, and it's asking cost backlink. So we just have backlink 1 over here, and now we need to now rename it as you can just keep it cost path or with the same name, or you can just name it as cost partner here. And uh, it's asking what would you like to keep your part type to be. So let's just keep it as each itself. So I'll just click OK, and let's just arrange it properly. All right, so it's getting connected now. So cost path is because of cost, distance, origin, and backlink and destination here. So let's just run it.